In 2016, this image went viral. Lee Sedol, one of the world's best Go players, had just been defeated by a machine. This wasn't just any match. It was a showdown between human intuition and artificial intelligence. AlphaGo had just played move 37, a move so unexpected and outlandish, it stumped the 200 million viewers watching. Go is a game with nearly infinite board combinations. This move had a 1 in 10,000 chance of being used. Move 37 not only helped AlphaGo win the game, but also upended centuries of traditional wisdom. It was a glimpse into AI's ability to transcend our understanding of data and offer creative solutions to complex problems. Today's machines are getting increasingly powerful. Some even surpass humans in the ability to generate strategic options. Human judgment still remains crucial in deciding which of these options are right for their organization.
How do we think about the combination of humans and machines from this point on? Are they substitutes or complements to each other?
There is a theory that explains how our casual acquaintances can introduce new, game-changing information. It's why networking events are so crucial for decision makers. People exchange ideas within their networks, drawing on diverse sources and recombining existing solutions to fit new contexts. What networks are to human strategists, large datasets are to machines. AI sifts through vast corpus of data. By recombining bits of information, AI can formulate strategies that might not be immediately apparent to even the most well-connected humans. Especially in a managerial context, this ability to pass large amounts of information simultaneously gives AI an upper hand.
So it's quite plausible that managers sometimes don't perform as well as machines do, right? Because there is a sort of decision-making heuristics that managers tend to follow. So there's work in the psychology literature, for example, that says that managers, especially when they are exposed to an unfamiliar domain, tend to extrapolate from whatever they know, and they end up creating a small world representation based on what they know.
And then there's success bias, another challenge of a human outlook to strategy. We love to talk about the hits, like the iPhone launch or Netflix's move to streaming. But what about the misses, like Google Glass or the Windows Phone? These weren't necessarily bad ideas, just poorly executed. Success bias means we often miss out on these lessons, and it can really skew our understanding of what makes a good strategy. Errors in comprehension are not just a human issue. It can seep into our datasets too, potentially impacting the predictions. This is where an LLM's capability can truly shine. By aggregating and ensembling multiple predictions, LLMs can potentially offset individual errors and produce better outputs.
And the reason is that across different literatures, including social sciences and machine learning, the finding is that if you aggregate many imperfect predictions, the aggregate prediction oftentimes becomes better. And the reason is that errors may partially offset each other.
In his recent paper, Professor Bart speculates that this aggregation is especially useful in strategic decision-making, where it is very likely that a single prediction is often incorrect or wrong to some degree.
And the reason is that these strategic decisions are very difficult, right? So they might be unique, you may not have all the data. So it's very likely that an individual prediction or individual decision maker will not get it right. So specifically under those settings that aggregation gives benefits. And also what the prior literature suggests is aggregation works best when you introduce diversity in these predictions so that the errors partially offset each other.
While aggregation helps in reducing the errors of prediction, it raises a critical question.
The minute you start to aggregate these pieces of information, maybe the machines are giving you somewhat of a weighted average of the content, both from a breadth and a depth perspective. But What you want as a manager or for your firm is to be able to distinguish yourself from the rest of the breed. What should then humans do to push the machine to not give them the averages?
This is where human intuition and contextual understanding come into play. Managers should be able to identify nuances and subtleties that AI might miss. But would managers have asked the right questions to prompt such insights? That remains a critical consideration.
So there are reasons to believe that the sequence of augmentation would matter. If the humans essentially go first, you could think about humans giving them more context, saying that, okay, I know that there are these 15 options that are completely irrelevant for the question that I asked you or for my context, and then asking machines to think more deeply about the rest of the options. On the contrary, if the opposite happens, could well be the case that machines generate a whole range of options that humans don't understand. So the real question is, what will be the augmentation sequence that minimizes both kinds of type 1 and type 2 errors, right, for false positives as well as false negatives? To me, it seems like there could be somewhat of a bias that the sequence of humans followed by machines might actually work better, simply because of the contextual anchoring that humans might be better at providing machines.
Up until 2003, Kodak dominated the global traditional film photography sector. While there were attempts to adapt to the rising demand for digital photography, a series of strategic missteps led to Kodak filing for bankruptcy in 2014. One key juncture in Kodak's long decline was when CEO Colby Chandler chose to diversify its verticals into development chemicals and imaging peripherals by acquiring companies like Sterling Drug.
But if you think about it, this is exactly what Fuji did, and Fuji succeeded. The problem with Kodak is that the subsequent CEO, who was George Fisher, came and reversed the entire thing. And he tried to go digital through partnerships with Microsoft and the like. It turned out that was, in my opinion, the wrong move. So here is an example of somebody coming up with this quote-unquote outlandish solution that the stakeholders rejected. So same thing, right? Machines could come up with something that is outlandish. That might have been right in hindsight, but it still requires these humans to sign on to these things, right?
Kodak's story underscores the challenges of integrating these outlandish ideas into an organization's strategy. This brings us to our next question. To what extent can we trust AI to participate in strategic decision-making? One big challenge in trusting AI-suggested ideas is the unreliability of the corpora it is trained on. Today's datasets are built on vast amounts of information collected over centuries. So when a machine tells you something, there's a strong chance it might be correct. But there's also the risk that the data carries biases from its sources. These can extend to race, gender, geography, political views, and more. Not just from historical data, but leanings of the data creator or the prompter. AI trained on this kind of data can amplify these biases, leading managers to potentially biased conclusions.
This issue of trust is going to be a big deal, right? Because I don't think these solutions can work without quote-unquote proper governance policies about what might be the right set of corpuses to train the data with, in order for these systems themselves to overcome the set of biases that they are essentially culpable to at this point in time. Let's say you're trying to acquire a firm. Would you say yes or no to acquisition of a firm from a particular country? Or would your thresholds for evaluating companies from certain countries be different from those that are, let's say, domestic? The efficiency of your R&D, would you involve, for example, people from other nationalities? What about involving people for certain kinds of tasks that are widely believed to be very gender specific?
In 2018, Amazon developed an AI recruitment tool to screen resumes and identify top candidates. However, it was discovered that the tool was biased against women. Questions were raised. Can firms rely on AI without verifying the source of their datasets? Can this data be cleaned of all biases? While technological companies are working on making AI bias-free, proper governance is yet to set in. Even with clean and reliable data, AI can sometimes produce unexpected results. These are called AI hallucinations, ranging from minor inaccuracies to significant errors. What we see as AI hallucinations might just be machines recombining information in ways that humans don't understand. Where does that leave managers and their machines?
The philosophical question then to answer is that machines really being creative? Creative for what? If it can never be implemented, then what's the reason to be creative? So maybe the way to think about options is that there are only a finite set of options that are practically implementable, and maybe that's the creativity that we care about.
An idea suggested by AI, however outlandish, could also move the dials of risk-taking. For managers, risks are unavoidable. Strategic advantage is taking high-return decisions while managing risks associated with them. If AI has been helping humans with ideation, with enough context, could AI also suggest ways to manage the risk associated with these ideas?
At the higher levels of the organization, I don't think managers can or want to avoid risks as much as they want to manage them. What would happen to the fortunes of the organization, but what would happen to his or her jobs as well? While the machines can give you the most likely scenario and maybe more precise in terms of the actual risk that a particular decision involves, the decision of whether to bite the bullet and take that risk versus not is going to still involve a bit of human judgment.
AI had predicted COVID-19 early on. Despite its early detection, one could argue that the lack of preparation and improvised responses by governments were a failure. Taking bigger risks and executing great ideas sounds like a good managerial trait, but there are occasions where addressing risks becomes vital. For instance, in 2008, Tata Motors unveiled the Nano, an ahead-of-its-time low-cost car designed to meet the needs of millions in India who couldn't afford a traditional car. Despite making groundbreaking innovations and overcoming socio-political challenges across the country, the car failed to create the success it envisioned. When asked how it could have helped in the Tata Nano case, a popular LLM suggested ways to navigate political unrest by working with the community, thereby managing the risk and also creating a better image among the customers.
They had this risk, the commodity prices went up, there was political risk as well that escalated, but they still did not back out from going to the market with a Tata Nano, which was priced less than $1 lakh. But that is still human decision making. Even assuming that the machine saw that risk coming in, it's not clear whether they would have scaled back on their ambitions, because that was the human part.
A decade ago, Move 37 showed the world how AI could take creative steps away from traditional decisions, given it understands the rules of the game.
If you think about Move 37, there were two interesting things that happened. Right? One is that when that move was played by the machine, the commentators and the experts thought it was an outlandish move. Nobody thought that it had strong logic behind that move. But what also happened subsequently was just as interesting, which is that the humans went back to the table and figured out what might have been the reason why the machine played Move 37 and started to learn from it.
AI will fire up human imagination in ways that we haven't conceived before. And it's quite plausible that our ability to execute these ideas could co-evolve together with AI's creativity. We might see more of this complementarity in the future.
it's quite plausible that these so-called outlandish moves are subsequently parsed by human beings and understood better, which might in the long run improve our ability to implement ideas or options generated by the machines themselves. What we think is outlandish or incredibly risky or bad ideas might eventually find their way into managerial decision making as well.
After that 2016 showdown, Go players closely studied all 5 games to relearn new ways of playing. A decade later, humans managed to beat that same version of AlphaGo, with some help from AI. It's fascinating, this co-evolution of human and machine strategies. It is not so much about one outperforming or substituting the other. It is about how we can learn from each other, adapt, and push the boundaries of what's possible together.